Welcome to the Baseface Network.
Hello, my name is Umi Nazira. Due to our course, Mathematics of GIS, you are given task to talk about vector analysis, raster analysis, point in polygon, line and area on area. So, in this video, me and my friend will be explain about it. Hi, we meet again. So for the first, I will be explain about vector analysis. Vector analysis is a branch of mathematics that deals with quantities that have both magnitude and direction. Some physical, geometric quantities called scalars can be fully defined by specifying their magnitude in suitable units of measure. Thus, mass can be expressed in grams, temperatures in degrees on some scale, and time in seconds. Scalars can be represented graphically by point on some numerical scale such as a clock or thermometer. There also are quantities called vector that require the specification of direction as well as magnitude. Velocity, force and displacements are examples of vectors. A vector's quantity can be represented graphically by a directed line segment symbolized by an arrow pointing in the direction of the vector's quantity, which the line of the segment representing the magnitude of the vector. So here is the example of vector analysis.
Hello everyone, let's learn a raster data. So, what is raster data analysis? A raster is composed and it is based on a measure of cells, or we call them as a pixel that arranged into rows and columns or grids. Raster data analysis can be done at level individual cell or group of cells or cell as a whole raster, where each cell contains a value that represents information such as temperature. A raster is a digital aerial photograph, imagery from a satellite, a digital photograph or a scan map. So this is the example picture of raster data. If we sound familiar, it is because this data structure is so familiar that it represents any digital image. A geospatial raster can be differs from a digital photo, in that comes with spatial information that links the data to a specific location. This includes the label and size of a raster cell, the number of rows and columns, and its coordinates reference system, or in the acronym they call it CRS. Okay, so what is a raster image? This is a type of image that is produced when scanning or photographing an object. Raster images are composed using pixels or tiny dots that contain unique colors and certain information that are combined to create the image. Since raster images are pixel-based, they depend on resolution. Although raster data structures are simple, they are very useful for many applications. In GIS, the use of raster data falls under four main categories. The first one is raster as a base map. The second one, raster as a surface map. The third, raster as a thematic map. And the last one, raster as an attribute of a feature. Next, why in many data analysis that can be and why GIS store data as raster. Sometimes you don't have the option to save your data as a raster. For example, imagery is only available as raster. However, these are many other features such as point and measurement that can be stored as cluster of future data types. It is also because there's a lot advantage of saving your data as a raster as follows. That is, number 1, simple data structure with each matrix of cells with values representing coordinates and sometimes associated with attribute tables. Number 2, raster analysis that powerful in format for spatial analysis and advanced statistics, and ability to represent continuous surface and perform surface analysis. Also, ability to store points, lines, polygons, and surface uniformly. And the last one is ability to perform fast overlays with complex data sets. Next, explanation area in area. Okay, area is a quantity that expresses the two-dimensional size of a defined portion of a surface. Typically, the area bounded by a closed curve. The term surface area refers to the total exposed surface area of a three-dimensional solid, such as the total exposed side area of a polyhedron. Area is so important in the differential geometry of surface. In GIS network analysis, a type of network analysis for determine the region that encompasses all accessible streets, that is, streets that lie within a specific impedance. For example, the 20-minute service area for a network location, such as the fire station, includes all the streets that can be reached within 20 minutes from that location. From the picture given, there is a sample image of area analysis. So, that's all from the explanation from me. Thank you.
Hi, hello and Assalamualaikum. So today I want to present to you guys about what is point of polygon. So point of polygon is one of the GIS operation that related to vector overlay. Then points on one of the data set are overlaid to polygon of another to determine the location of points in the polygon. There are two ways point of polygon being called, which is edges and side. And the points where two edges meet the polygon's vertex. So how to find a point of polygon? One simple way of finding whether the point is inside or outside the simple polygon is to test how many times a ray starting from the point and going in any phased direction intersects the edges of the polygon, and if the point is on the outside of the polygon, the ray will intersect the edge in even number of times. In computational geometry, the point in polygon problem asks whether a given point in the plane lies inside, outside, or on the boundary of a polygon. So there are two types of polygons, which is convex and non-convex. If a number of points are to be tested against a polygon, it may be worthwhile determining whether the polygon is convex at the start and so be able to use a faster test. So in polygon, there are algorithms that benefit from having a bounding box around polygons with many edges. The point is first tested against this box before the full polygon test is performed. If the box is missed, so it's the polygon. Thank you. So what is the line in area? A line is one of the three features with which most vector data is represented in GIS map. There are points and polygon. Lines are used to represent the shape and location of geographic objects such as street, center lines, and string. To narrow to depict as areas, lines are also used to represent features that have lengths but no area, such as contour lines and boundaries. A line is formed by connecting two data points. A computer reads this line as trace and render the line as a vector. What is vector? Vector is any quantity that has both magnitude and direction. The more points used to create a line, the greater the detail. GIS software can be used to define one end of the line as the starting points and the other as the end point, giving the line direction. Adding more vertices or points allow curvature to be displayed. The image below shows the difference in detail between fewer and more vertices. So here the example. As you can see, there are 4 example by network rules. The line between 7 point, 14 point and 21 points. So they are the identity of line. The line is identified by the sequence of first and last point together with executable attribute. In the image that I give here, the three lines A, B and C have their first and last node identify their location. Each line also has attribute of flow and capacity. Each node has coordinate X and Y. They are used in another table. Because the first and end node coordinate of each line is known, the both of line or polyline sequence of lines can be easily computed. Thank you.
So this is the end for our video. I hope the explanation are clear enough to make you guys understand this topic. See you again.